to go to space, right? Okay. Next, okay, all right. So now we come to the questions from 2018 on space, right? The first question is, consider the following statements. Light is affected by gravity. The universe is constantly expanding. Matter warps its surrounding space-time. Matter warps its surrounding space-time. Now, which of the following is our predictions of Albert Einstein's general theory of relativity, often discussed in media? So directly UPSC is picking up things from newspaper. Especially UPSC tends to like Einstein's theories, right? Because that is the theory of Einstein is related to gravitational waves also. Right, so let us understand the concept. See, theory of relativity is two theories, right? Special theory of relativity and general theory of relativity. That was given by Albert Einstein. Right, special and general relativity. The general theory of relativity is often called as just general relativity. In 1905, Einstein gave the theory of special relativity, which showed that space and time were connected, interwoven in a single structure, and he termed this as space-time. But after 10 years, in the next 10 years, he worked to include or incorporate gravity into this picture, which resulted in general relativity. Now, Einstein's theory uses the idea of space-time. Now, space-time is the fact that we have four-dimensional universe, three in space, length, breadth, and height, and one is time, right? One dimension is time. So any event, physical event that happens, it happens in space and time, right? Four dimensions. So according to general theory, any mass, right? Any mass causes space-time to curve. Any mass, even me, you, a pen. But the point is, we cannot observe these small warpings of space and time. We can only observe warping of space and time of big celestial bodies like sun, black hole, or big galaxies. You and I, right? An elephant, a donkey, anybody who has mass warps the space-time, but it is not observable. Observable is of the massive celestial bodies, right? So all objects bend space and time, but it only becomes visually noticeable for very big objects. As you can see here, this is the space-time. This is the fabric of space-time, just like fabric of a shirt or a pant, right? And when a massive object sit in this fabric, so fabric like this, and the object is sitting, so it bends like this, right? If there is no object, the fabric will come back, right? So statement 1, according to Einstein theory, light, just like any other form of matter, is affected by the gravity. This is called gravitational lensing. Statement 2, so statement 1 is correct. Statement 2, Einstein was initially favoring a static universe. Favoring would come here, but a discovery by the American astronomer Mr. Edwin Hubble changed his mind. Hubble's observation showed that the universe was expanding, and this model, right, was later known as the Big Bang. So the expansion of universe was first observed through the redshift of the galaxies. Focus on these terms: redshift, gravitational lensing. These are all part of connecting the dot, right? So the terms that are related, or the topics that are related: special relativity, gravitational lensing in dark matter, time dilation, steady state theory, real world applications like the use of general relativity in GPS technology, red shifting, concepts of gravity, Newton versus Einstein. So there is a link which I have provided, www.skyatnightmagazine.com. They have a wonderful explanation of the differences of the concepts given by Mr. Einstein and Newton. So they have given different concepts of gravity, right? Please do read that. Okay. The answer is D. 1, 2, and 3 all are correct.